Okay, students, good morning. Uh, Today, we are going to start with a new topic, which is known as comparators. So, can anyone of you tell me a brief description about last class? What we have mentioned? The last class we have, what we are discussing about. Any one of you? Somehow, can you tell me what were you discussing in the last class?
Optical measurement instruments.
Yes, Vishnu. Yeah, thank you. So it was like optical measuring instruments, and there are of three types of optical measuring instruments. Can any one of you name them? I'll ask to Karthik. Karthik, can you just name them? What are the three types of optical instrument measured? Actually, I have showed you the figure everything while explaining also. There are basically three types. Karthik Koteri, I hope so.
Yes,
You
sir.
heard me. Yeah. And just tell
Yes,
me the names
vertical,
of
horizontal.
vertical optimeter, horizontal optimeter, and the third one is
Microscope.
that is toolmaker's microscope, right? It is the most common one. Okay, then. Thank you. Then, so today we are going to start with the comparators. So I hope so. My screen is visible for everyone, right? So
Yes, sir.
okay, fine. Then, so we will start with comparators. So okay, so this all are we are discussing about the various types of measuring instruments and measuring setups, everything. So here we are going to today we are going to discuss mainly about the comparators, its types, then in if possible the surface roughness also. So now we'll start with comparators. So comparator is a device which is generally used to measure the dimensional difference. So in this case, what happens is mainly comparator. Comparator is mainly a device which is generally used to measure the dimensional differences, and then that means it does not show the exact dimension but only shows the deviation of the dimension from the standard dimension. So already in this case we will be having a standard dimension, where the comparators, it is a device, it is also a measuring device. Okay, so the comparators comes under, like, comparators are mainly of three types, that is of mechanical, electrical, optical, and pneumatic. As per our requirement, it is been subdivided into three to four types. Okay, so mainly it's coming with mechanical, electrical, pneumatic, and optical comparators. So again, there are various types of comparators. The name mainly the syllabus we are discussing about these four types of comparators, three to four types of comparators. And that mainly the first three are the highly applicable for our purposes in the case of the aspect of engineering. So in the case of comparators and its types, it is a device. It is mainly a device which is generally used to measure the dimensional difference. Okay, it is a device which is generally used to measure the dimensional difference. That means it does not show the exact dimensions. That means it doesn't show the exact dimensions, but only shows the deviation of the dimensions from the standard dimensions. Okay, that's in the comparators and its types. It is a device which is generally used to measure. It's a device which is generally used to measure the dimensional difference. It is a device which is generally used to measure the dimensional difference. That means it does not show the exact dimensions. That means it doesn't show the exact dimensions, but only shows the deviation of the dimensions. But it only shows the deviations of the dimensions from the standard dimension. Deviations of the dimension from the standard dimension. Then the comparators are kind of linear measurement device. Okay, the comparators are kind of linear measurement device, where comparators can be broadly classified as follows, like mechanical comparators, pneumatic comparators, electrical comparators, optical comparators. There are various types of comparators. So in one word, we can say it's a device which is generally used to measure the dimensional difference. But the difference when compared to others is that means it does not show the exact dimensions. Okay, but it does not show the exact dimension, but it only shows the deviation of the dimensions. That is a change in the length or length on the measurements. That is a change in the deviation of the dimensions from the standard dimensions. Okay, so I hope so you remember what are the standard aspects which were named before. Okay, so which was discussed in the third module. So now the comparators are kind of, it is also a kind of linear measurement device. The same word which we have used where before. Can anyone of you say? Previously, Vision, can you tell me where we have used this the same word, the linear measurement device? Sridhar Vijayan, are you available there?
Sir,
Can you tell me where we have used this linear measurement device before? Okay,
roundness,
mail, where?
roundness,
In the case of roundness, then also in the case of our optical measurements, everything. Fine. Okay. So generally, so in this case, so it is a linear measurement devices. So the comparators can be hardly classified or broadly classified into four types. That is mechanical comparators, pneumatic comparators, electrical comparators, and optical comparators. So in the case of mechanical comparators, what happens? The mechanical comparators are generally used for, okay, the mechanical comparators are generally used for the inspection of components in workshop. It is mainly used for the components in workshop, okay, and tool room industry, etc. Even small deviations can also be magnified in the mechanical comparator. The mechanical comparator is again further classified into two types, that is dial gauge or dial indicator, and second one is read type mechanical comparator. It's again classified in two types. I hope so you are just noting down the heading so that you will not forget what are the comparators. Then comparators, we have four types. The first one is mechanical comparators. In that mechanical comparators, again we have subdivided into two types. That is dial gauge or dial indicator. Second one is read type mechanical comparator. This dial gauge or dial indicator you might have seen in your laboratory while doing the experiments. Okay, as you have done the experiments. Okay. So in the case of manufacturing technology lab 2. So here what we have is a mechanical comparator. So the mechanical comparators are generally used for the inspection of components in the workshop. So the mechanical comparators are generally used for the inspection of components in workshop and tool room industry, etc. Okay, so in the case of mechanical comparators, it is generally used for the inspection of components in workshop. It's mainly used for inspection of components in workshop and tool room industry, etc. Okay, the inspection of components in workshop and tool room industry, etc. Then even small deviations, okay, even small deviations can also be magnified in the mechanical comparator. Okay, so even small, very small deviations can also be magnified in the mechanical comparator. Then the mechanical comparators further classified into two types. Okay, the mechanical comparators further classified into two types. First one is dial gauge or dial indicator. Second one is read type mechanical comparator. Okay, first one is dial gauge or dial indicator. Second one is read type mechanical comparator. So this is what happens in the case of a mechanical comparator, where the mechanical comparator are generally used for the inspection of components in the workshop and tool room industry, etc. Then even small deviations, okay, even small deviations can also be magnified in the mechanical comparator. So even the small deviations can also be magnified in the mechanical comparator. Then the mechanical comparator is further classified into two types. First one is dial gauge or dial indicator. Second one is read type of mechanical comparator. This is what happens. So in the case of dial gauge or dial indicator, okay, in the case of dial gauge or the dial indicator, this is the figure. Okay, so by the meantime, you just look on the figure and just note down, or just look on what are the parts available in that dial gauge. Okay, anyway, you have seen this instrument in our manufacturing technology lab and you have done the experiments, the calibration, everything. Am I right, Vishnu AP?
Yes, sir.
Yeah.
Yes, sir.
So, okay. So, fine. So, like in the case of this, what happens? Now you see dial gauge. In the case of dial gauge, what happens? Dial gauge or dial indicator, what happens? It is the gauge. The dial gauge is a device which is widely used to what is the main purpose of a dial gauge? It is mainly widely used to compare the dimensions with standard dimensions. Okay, so I hope so you remember what are the standard conditions for dimensions. We have named certain BIS, ISO, so many things. Remember, so it's a very important thing. So you just not sure. Remember, in the third module or fourth module we have described that. So here, what happens is we have a dial gauge or dial indicator, which is named as dial gauge or dial indicator, where the dial gauge is a device which is widely used to compare the dimensions with standard dimensions. Here, what happens is we have a dial gauge. It is a device. It's a device which is used to compare the dimensions with standard dimensions. Okay, it is used to compare the dimensions with standard dimensions. It is mainly used, it's widely used to compare the dimensions with standard dimensions. Then it consists of a case, circular, graduated dial, steam, spindle, pointer, gear train, and contact point. So this is what happens in the case of dial gauge or dial indicator. So in the case of dial gauge or dial indicator, the dial gauge is a device. It is mainly a device which is used to compare the dimensions with standard dimensions. So it is mainly just used to compare the dimensions. It is mainly used to compare the dimensions with standard dimensions. That it consists of case, circular, graduated dial, steam, spindle, pointer, gate train, and contact point. So all these are the other setups, like in the case of dial gauge. So in the case of dial gauge, what happens is it is a device which is widely used to compare the dimensions with standard dimensions. It is merely used to compare the dimensions with standard dimensions. That it consists of a case. You have seen the figure. Okay, the outer part. See the outer. So here what happens, the outer part is called the case. See, this is the outer part, this is called, so this is called the case. Okay, the outer part is called the case. Then we have a circular graduated dial. Okay, this is named as a circular graduated dial. Okay, this is the inside part is called the circular graduated dial. Then we have a spindle, pointer, everything. So this is the pointer, and then we have a small arm, spindle, gear train, and contact point. All this. Okay, contact point is this point. Okay, this is the base is the other plunger. This is the contact point. Okay, then pointer, then smaller arm, then case, then graduated dial. All these are features. Then when the contact point, okay, so when the contact point, what happens, touches the standard specimen or master, the dial gauge is set to zero by rotating the case. So what happens, as you remember, we have already done the experiment. I'll just tell how we are doing the requirement in the case of dial gauge, where when the contact point touches against a standard specimen or master. Okay, so here what happens, this is the contact point. Where do we find the contact point? This is the contact point. Soon after the plunger, we find the contact point. Okay, soon after the plunger, we find the contact point. Okay, so here what happens is, soon after the plunger, we have the contact point. Soon after the plunger, we will be having a contact point where the dial gauge is set up. Okay, where when the contact point touches against the standard specimen or master. Okay, the dial gauge is set up. So when the contact point touches against the standard specimen or master. Okay, so when the contact point touches the standard specimen or master, and the dial gauge is set to zero by rotating the case, and the dial gauge is set to zero by rotating the case. Now the standard specimen is replaced by the workpiece. Here we have got a standard specimen which is replaced by the workpiece. So now the dial gauge will show the reading with the help of a moving pointer in the graduated dial. In case there is no variation in the workpiece dimension as compared to standard specimen, the pointer will always show the zero reading. So this is what happens in the case of dial gauge. I'll tell one more time, like what happens when the point touches against the standard specimen. So there is a specimen, and when the contact point, where we have seen the cursor, this is the contact point. So when the cursor or when the point touches, okay, touches against the standard specimen, the dial gauge is set to zero by rotating the case. By rotating the case, what happen? We can set the dial gauge to zero. Okay. Then now the standard specimen is replaced by the workpiece. Now the standard specimen is replaced by the workpiece. Now the dial gauge will show the reading with the help of a moving pointer in the graduated tail. Now automatically what happens, without the, now we have replaced the standard specimen with the current workpiece, and then it will be showing the reading with the help of moving. In case there is no variation in the workpiece, in very minute cases there will be no variation in the workpiece dimensions as compared to standard specimen, then the point will show zero reading. So generally the contact point is an interchangeable one. So it may be standard point, tapered point, or button regarding the flat. Okay. So this is what happens in the case of a dial gauge. Okay. So this is what happening in the case of a dial gauge. Okay. Then what happens is, second one is regarding the reed type mechanical comparator. Okay. Second one is regarding the reed type mechanical comparator. Okay. Second one is the reed type mechanical compact mechanical comparator. Okay, this one is a reed type mechanical comparator. So in this case, what happens, we have a reed type mechanical comparator. You can see it consists of a plunger. Okay, it mainly consists of a plunger, contact point, movable member, fixed member, pointer, and graduated scale, etc. So this is a figure. Okay, so you can see again the figure. So here what we mention is, this is regarding the reed type mechanical comparator. So here in this case we have a reed type mechanical comparator, where in this case it consists of a plunger. Okay, it mainly consists of a plunger, contact point, movable member, fixed member, pointer, and graduated scale, etc. So initially, so what happens is, initially the comparator is set to zero. So at the initial stages, what happens is, initially the comparator is set to zero. Okay, at initial stage, what happens is the comparator is set to zero. It consists of a plunger, contact point, mobile member, fixed member, pointer, and graduated scale, etc. So initially, the comparator is set to zero scale with the help of a standard specimen. Okay. So it consists of a plunger, contact point, mobile member, fixed member, pointer, and graduated scale, etc. So in this case, initially what happens, the comparator is set to zero scale with the help of a standard specimen like slip gauges. So can any one of you explain me what do you mean by slip gauge? I can ask to Muhammad Shahzad. Muhammad Shahzad, can you tell me, you have already seen in the laboratories regarding the slip gauge. So what is the for in the laboratory? What was the purpose we are used for slip gauge, and what was the requirement? Muhammad Shahzad. Muhammad Shahzad, are you available? Fine. Okay, then I can ask to Agilam. Am I audible?
Yes, sir.
Sir.
Agilam, can you just tell me what is the purpose of a dial gauge or slip gauge? No, no, dial gauge, slip gauge. Sorry, slip gauge.
Precision length measure ये
Okay, so where did you find the slip gauge before?
in the lab, empty lab.
In the manufacturing technology lab. So, what was the application of the slip gauges in the MT lab?
Application.
Uh.
The
We have
measuring
used we have used this slip gauges for many experiments, right? What was the purpose?
To find out the error.
Yes, that's what. Here comes Karthik. Thank you. The standard deviations. Okay, so in slip gauges, automatically, what is the? It is a small bit of a metal where already the dimensions are marked, right? Am I right?
Yes, sir.
Yeah. So when the dimensions are marked, and then we are using an instrument. In some case, it might be vernier scale, micrometer, dial gauge. So many instruments were calibrated. Calibrated means we will be already having a set value in the slip gauge, and by measuring with the instrument, it understands there's a standard deviation. That deviation is marked, and then we calibrate the vernier scale, everything. Right? Do you remember? So that's what. So here in this case, what happens is we have a real-time mechanical comparator where as we told, the comparator is also a device which is generally used to measure the dimensional difference with respect to the standard deviation. So what happens here? It is a real-time mechanical comparator. So this real-time means it comes under a subdivision of a mechanical comparator. So in mechanical comparator, there are again two, which is one is dial gauge, which we are discussed now. The second one is a real-time mechanical comparator. So in the case of a real-time mechanical comparator, it consists of a plunger, contact point, movable member, fixed member, pointer, and graduated scale, etc. So this all will be present in the case of a real-time mechanical comparator. So it consists of a plunger, contact point, movable member, fixed member, pointer, and a graduate scale, etc. So initially, what happens is the comparator is set to zero scale. So in this case, initially what happens, always the comparator is set to zero scale with the help of a standard specimen like slip gauges. It's mainly with the help of a standard specimen like slip gauges. Then the workpiece is kept at the bottom of the plunger. Then the workpiece is kept at the bottom of the plunger. So the contact point will touch the surface of the workpiece. So the contact point will touch the surface of the workpiece if any variations occurs. So the contact point will touch the surface of the workpiece if any variation occurs. Then the plunger will move upward. Then the plunger will automatically move upward. This happens in the case of a real-time mechanical comparator. So in the case of a real-time mechanical comparator, what happens is it consists of a plunger. So in the case consists of a plunger, contact point, movable member, fixed member, pointer, and graduated scale, etc. So initially, what happens? Initially, the comparator is set to zero scale. So initially, what happens is the comparator is set to the zero scale with the help of a standard. Sorry, with the help of a standard specimen. So initially the comparator is set to a zero scale with the help of a standard specimen like slip gauges. Then the workpiece is kept at the bottom of the plunger. Automatically what happens? Then the workpiece is kept at the bottom of the plunger. So the contact point will touch the surface of the workpiece. So in some case, what happens? The contact point will touch the surface of the workpiece if any variation occurs. Then the plunger will move upward. Then automatically what happens? The plunger will move upward. Okay, automatically the plunger will move upward. So generally the plunger is attached to a movable member. Due to the movement of plunger, the movable member also will move. So in this what happens, generally the plunger is attached to the movable member. So automatically when there's a disturbance, the movable of the plunger will be taking place. So the reeds are connected with the movable member and the fixed member. Due to the movement of reeds, the pointer will move on the graduated state and shows the read. And this is how the reading has been shown. So we will be having a plunger which is attached to a movable, okay, it's a movable member and a fixed member. So when there is a deviation, automatically the movable member will move, and due to the movement of the reeds, what happens? The pointer on the scale, the graduated scale will move, and which shows the reading. This is what happens in the case of a reed type mechanical comparator. And why do we use this mechanical comparator? Because the reed type mechanical comparator is very simple in construction. At the same time, it is very cheaper when compared to any other set. Then the main helpful is it does not require any other device or external power supply. Then another, it is small device, so it is portable, you can move it here and there. Then it's also easy in design and easy to handle. So these all are the advantages which makes it suitable for all the purpose for mechanical application. So the major disadvantage also is there, like it has a frictional parts will come to play. Then the movement of the rack and pinion. So automatically what happens in some cases, it may affect the accuracy and precision if it is not cared properly well during the movement. So these are the both advantages, but when compared to the advantages, the disadvantages are comparatively negligible. So what happens? It is widely used since it is cheaper than any other comparator, and it is a robust, compact, and easy to handle. So these are the specifications make it a widely used comparator when compared to the other comparators. So this real-time mechanical comparators comes under the mechanical comparator. Then what happens is the second one, which the second one was regarding the pneumatic comparator. Okay, the second one was regarding the regarding the pneumatic comparator. Okay, the second one was the regarding the pneumatic comparator. Okay. So in this case, now we have a pneumatic comparator. Okay, here we have a pneumatic comparator. So this pneumatic comparator is a second comparator which comes under the case of a comparator. So first one was the. Can anyone tell me what was the first one? And this Suresh can tell me the first one. And this Suresh, are you there? Can you just tell me the first one?
Yes, sir.
First one was the.
First,
I have told everyone to write just at least the headings in the notebook. Why you guys are not doing it? And it was why you are not doing it? I just told to write the note, at least the headings in the notebook, so you will have an idea what the topics has been covered, right? Anirudh?
yes, sir.
Okay. The first one was mechanical comparator. Okay. In the mechanical comparator, we had two types. Can you tell me that at least, Anirudh? In mechanical comparator, we had two types. What are they? What are they? Andrew, the question has been asked to you. If you don't know, just tell me don't know, not a problem.
Yes, sir.
Okay, fine. So we will start with the pneumatic comparator. So here we have a pneumatic comparator. So in this case, what happens is a pneumatic air. So here what happens, a pneumatic air is used as a working medium in the pneumatic comparator. The name pneumatic itself comes air. So here what happens is we have a pneumatic comparator. So In this case, what happens is a pneumatic. Again, the pneumatic comparators are again subdivided into flow or velocity type or back pressure type comparator when compared to that of mechanical comparator. So, the case of a pneumatic comparator. So, pneumatic comparator comes under the division of a this thing. So, what happens is the pressurized air. Okay, the pressurized air is used as a working medium in the pneumatic comparator. Okay, the pressurized air is used as a working medium in the pneumatic comparator, and there is no metal contact of gauge and workpiece, and there is no metal to metal contact of gauge and workpiece. So hence what happens, hence the accuracy of measurement is increased, and the amplification range is also increased without the reduction in range as compared to mechanical or electrical comparator, as compared to the mechanical or electrical comparator. So the pneumatic comparators are classified as follows. First one is the flow or velocity type pneumatic comparator, and the second one is the back pressure type pneumatic comparator. So this is what happens with respect to pneumatic comparator. So it is used as air as the working medium in the pneumatic comparator. Then there is no metal to metal contact of gauge and workpiece. Here there is no metal to metal contact of gauge and workpiece, and the accuracy of the measurement is increased, and the amplification range is also increased. Okay, without the reduction in range as compared to mechanical or electrical comparator. Okay, without reduction in range as compared to the mechanical or electrical comparator. Then the pneumatic comparator classified as follows. First one was the flow or velocity type pneumatic comparator. The first one was the flow and velocity type pneumatic comparator. Okay, the first one. So what happens is, now while looking the just before doing just look on the figure and just see what all are the components which are present in the flow or velocity type pneumatic comparator. Just see and look on the see and see what are the various types of flow present in the pneumatic comparator. In 2 seconds. Okay, just note down the heading and just look into what the compressor, filter, what are the major parts of the field which is found in the pneumatic comparator. Okay, that's what I'm saying. So now I hope so you are drawn the not drawn. You are just seen. You have this overview of what are the parts available in a flow or velocity type pneumatic comparator. So you have seen the parts name, right? Amit, do you have seen the parts name? Amit, guys, am I audible? There's an issue.
Yes, sir.
Yes,
Okay.
sir.
Amit, okay. Tell me, you have seen the parts. Okay, parts of this. So what is the parts? Can I just read it? It's there on the screen. Amit, guys, is there any connectivity issue? No. Can you hear me what I'm saying?
Yes, sir.
Yes, sir.
Huh. Okay, Asaf, then can you tell? Okay, Amit is busy, I think so. So can you just tell me, Asaf,
Compressor,
compressor, filter,
filter,
okay, tapered
shut-off
supply,
valve,
shut-off valve, then pressure regulator, hose,
hose,
clearance air gap, measuring device. All these are the
hose.
components. Okay, fine. So what I'm saying is, in the case of a pneumatic comparator, thank you, sir. So in the case of a pneumatic comparator, what happens? We have a air which is used as a working medium in the pneumatic comparator, and then there is no metal to metal contact of gauge and workpiece. Hence the accuracy. Hence what happens? The accuracy of the measurement is increased and the amplification range is also increased without the reduction in range as compared to mechanical or electrical comparator. Then the pneumatic comparators are classified as follows, as we have two types of pneumatic comparators. The first one is flow or velocity type pneumatic comparator, and second one is back pressure type pneumatic comparator. So what happens is we have a flow or velocity type pneumatic comparator. Where the first one is the arrangement of the flow or velocity type comparator. Okay, the arrangement of flow or velocity type pneumatic comparator means it consists of a compressor, then FRL unit, valve, tapered glass tube, float, and gauging head. So, and various other components as you see in the figure. So, what happens is here, what happens, I'll just tell you working so that you will have an idea of it. The pressurized air in the range of 1.5 to 2 bar, that is from the compressor. Okay, so you are seeing the air supply, which is noted in the figure. So, what happens? The pressurized air in the range of 1.5 to 2 bar is supplied through a tapered glass tube. Is always supplied through a tapered glass tube that contains a float. Okay, so that contains a float. Then the air passes through the hose. What happens is then the air passes through the hose and exits to the atmosphere. Okay, then the air passes through the hose and exits to the atmosphere through the gauging head. So what happens is here the pressurized air is ranging of 1.5 to 2 bar is supplied through a tapered glass tube. Is supplied through a tapered glass tube that consists of a float. It's mainly supplied through a tapered glass tube that consists of a float. Then the air passes through the hose and exits to the atmosphere. Automatically, then the air passes to the hose and exits to the atmosphere through the gauging head. Now the gauging head is inserted to the workpiece due to the clearance between the gauging head and the workpiece. Now what happens? Now the gauging head is inserted to the workpiece due to the clearance between the gauging head and the workpiece, where the flow of the air is also restricted. In this case, what happens? Where the flow of the air is also restricted. Thereby, what happens? Thereby, the position of the float is changing in tapered glass tube. What happens? Therefore, the position of the float is changing in the tapered glass tube. The compressed air is filtered. The compressed air is filtered by the help of filter and then lubricated and finally regulated to the required change. So what happens? We have got a compressed air which is filtered with the help of a filter and then lubricated and finally regulated to the required range. That's what happens in the case of flow or velocity type of train. Okay, this is what happens. Then, okay, then what happens? Here, what happens? A shut-off valve. Okay, a shut-off valve is present. A shut-off valve is present. Okay, what happens? A shut-off valve is present where? Yes, Amit, what's the issue? Amit? Shall I mute you, Amit? Okay, fine. So we have got a shut-off valve where a shut-off valve is used to air supply where not in use, and the air bleed and adjustment screw is set to 0 level of the gauge. This is what happens in the case of a flow. Okay, in the case of a flow or velocity type pneumatic comparator. Then the second one was named as what? Back pressure type pneumatic comparator. Then the second one was named as back pressure type pneumatic comparator. Okay, the second one was named as back pressure type pneumatic comparator. So in the case of back pressure type pneumatic comparator, what happens here? What happens is the arrangement of the back pressure pneumatic comparator where we have an orifice. You can see the figure where we have the orifice O2 which is fully closed. Okay, orifice O2 which is fully closed and supplies the pressurized air to the system, and it always supplies the pressurized air to the system until the pressure P1 and P2s. Okay, so this is the one until the pressure P1 and P2s are equal, until the pressure P1 and the pressure P2 are equal to 0. So when orifice O2 is open, then finally what happens? When the orifice is open, the pressurized P1 and P2 varies with reference to difference, the distance between the orifice O2 and the elevation of the surfaces in the workpiece. and also to the elevation of, if there is any deviation pressures of P1 and P2, then the deviation the pressure can be measured. And finally what happens, okay, the Solar's gauge is a good example for the pneumatic comparator. So this is what happens in the case of a, what happens in the case of a pneumatic comparator. So what happens, second one was the back pressure type pneumatic comparator. So in the back pressure type pneumatic comparator, where the arrangement of back pressure type, pneumatic comparator is shown, and is where we have an orifice which is fully closed. Okay, where we have an orifice which is fully closed and supplies the pressurized air into the system. What happens, and supplies the pressurized air into the system until the pressures P1 and P2 are equal, to 0. So when orifice O2 is opened, okay, so when orifice O2 is opened, the pressure P1 and P2 varies with reference to distance between O2. The pressure P1 P2 varies with the reference between O2 and to the elevation of surface in the workpiece. So if there is any deviation in the pressure P1 and B2, then the deviation of the pressure can be measured. This is what happens with respect to a pneumatic comparator with respect to a back pressure type. Then in the case of comparators, first one we were discussing about mechanical comparator, second one was regarding the pneumatic comparator, and third one is the electrical comparator. Okay, so third one was the electrical comparator. Totally we have four types. Third one was the electrical comparator. So in the case of an electrical comparator, means the electrical comparators generally depend on the Wheatstone's bridge circuit of measurement. Okay, in the case of electrical comparator, it mainly depends upon the Wheatstone's bridge circuit for measurement. In this comparator, we can get a high modification range of DC current, where the arrangement of the electrical comparator, is shown. It consists of an armature coil, amplifier, meter, plunger, and flexible strip, etc. So here what happens, the armature is placed between the two coils, where one end of the armature and the plunger is supported and the other end is connected to the flexible strip. In the case of an electrical comparator, I will just show you a small figure where you will have a simple idea regarding the electrical comparator. Okay, regarding the electrical comparator. So I'll just show a simple idea. So this is the figure of an electrical comparator. Okay, so this is the figure of an electrical comparator. Okay, so what happens is we have an electrical comparator where it generally depends on the Wheatstone's bridge. What's I'll tell you. Okay, then in this comparator we can get high magnification range. Okay, in this comparator we can get high magnification. In the case of electrical comparator, this mainly depends on the Wheatstone's bridge circuit for measurement. In this comparator we can get high magnification range. Okay, in this comparator we can get high magnification range where direct DC current is supplied to the system. So what happens is the armature is placed. Okay, in this case what happens is the armature is placed between the two coils. In this case the armature is placed between the two coils. Okay, the armature is placed between two coils, and one end of the armature is supported, armature plunger is supported, and the other end is connected to the flexible strip. So the amplifier is a device. In this case what happens, the amplifier, okay, the amplifier is device which is used to amplify the output signals. In this case an amplifier is a device which is mainly used to amplify the output signal. So what happens is the merit is like it mainly consists of less moving parts and the magnification range is high, and also we have an instrument which is comparatively compact. But in this case what happens, we require an external power supply, and the variations of voltage will always affect the output. In this case the variations of voltage will always affect the output. This is what happens in the case of an electrical comparator. So here what happens is Wheatstone's bridge, in this comparator we can get a high modification range of DC current. Okay, DC current, and the armature is placed in two coils. So here we have an electrical support, and the pneumatic we have an air support, the mechanical other support, and the final one is like the mechanical optical comparator. Okay, the final one is the mechanical optical comparator. So in the first case it was a mechanical comparator. Okay, so it is mainly in the workshops and industries with the help of the deviations. Okay, so we have dial gauge and real time mechanism. In this case it is named as mechanical optical comparator. Both are different. Okay, First case was mechanical comparator. That's why I told you mainly we are discussing about three of them, but the fourth one is also not much important, but we have to discuss. That's what I'm saying. This is mechanical optical comparator. Okay. So in this case, what happens is in the case of a mechanical optical comparator, again, I will show you a small figure representation. Okay, in this is the figure where we have a mechanical optical comparator. Okay, where we have a this is the figure. Okay, this is a figure which we have mechanical optical comparator. So what we can see is we have a light source, we have a condenser, we have a projection lens, then we have a mirror, then we have a screen, and then a plunger, then the workpiece. So this is what the case of a mechanical optical comparator takes place. Okay, so there are two types. That is one first one is mechanical comparator, and this one is mechanical optical comparator. Okay, and this one is mechanical optical comparator. So what happens is here, I'll just tell you in this type of comparator, I'm just taking a 5 more minutes just to finish this topic so that will be over. Okay, please excuse me. In this type of comparator, small displacements of measuring plunger are amplified by a mechanical system. So what happens is in this type of comparator, small displacement of measuring plunger are amplified by a mechanical system consisting of a pivoted levers, and this amplified mechanical system is again amplified by a simple optical system involving the projection of an image. So that's what happens in the case of a mechanical optical comparator. In this type of comparator, small displacements, okay, mainly small displacements, that's what happens. Okay, small displacements, in this case a mechanical optical comparator. Okay, small displacements of the measuring plunger are amplified by a mechanical. Okay, by a mechanical, that's what happens on measuring plunger are amplified by a mechanical system considering of a pivoted levers, where this amplified mechanical system is again amplified by a simple optical system involving the projection of an image. And in the case of optical magnification, which provides high degree of measuring precision, in the case of optical magnification, it provides high degree of precision due to the reduction of moving members and better wear resistance. That's what happens. So here what happens, we have an optical magnification system where a high degree of measuring of precision due to reduction of moving members and better wear resistance qualities. So in optical magnification, there is no friction, bending, and wear. If the surface of the workpiece is flat and smooth, in this case, if the surface of the workpiece is flat and smooth, the plunger will not have displacement. But if the surface is rough and up down, then the plunger will have moving the oval surface in the workpiece which have small displacement. That's the last point, where if the surface of the workpiece is flat and smooth, automatically the plunger will not have any displacements. But if the surface is rough and with ups and downs, and then the plunger moving over the surface of the workpiece will have small displacement. That's what we will be noting down. So this is what happens with respect to the comparators, and we have discussed about the comparators and the various types of comparators. That is the mechanical comparator, pneumatic comparator, electrical comparator, and the mechanical optical comparators. Okay, and now the next class we will be mainly discussing about the surface roughness. Okay, of the measurements. Okay, I'll just check the attendance by the meantime. We'll stop the class. Okay, thank you.